integration of x to the power n, any polynomial function, is x to the power n plus 1 divided by n plus 1. We know that from the property of the integral that minus a to a f of x dx will be equal to 2 times integral 0 to a f of x dx if it is an even function. 2-mark question basically have integration by substitute type of questions or integration by parts. Since we have changed the limit of the function also, no need to put it back the value of t again, just directly apply the upper and lower limit. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we are going to revise the chapter integrals. So let's see the chapter is weightage. So we know that in your question paper, we have 5 sections. So under part A, you will be getting 2 multiple choice questions from the chapter integral and 2 marks 2 question, 3 mark 1 question, 5 mark 1 question, 6 mark 1 question. So overall, the chapter has 20 marks. Let's take few objective questions. The antiderivative of root x plus 1 by root x is equal to, so options are given as 3 by 2 x to the power 3 by 2 minus 2 root x plus c, 2 by 3 x to the power 3 by 2 plus 2 root x plus c, 3 by 2 x to the power 3 by 2 plus 2 root x plus c, 3 by 2 x to the power 3 by 2 plus root x plus c. So when we apply the integration, so in the index form, x to the power 1 by 2 plus 1 by x to the power 1 by 2. So if we apply the integration for this, we know that integration of x to the power n, any polynomial function, is x to the power n plus 1 divided by n plus 1. So using this formula, this will become x to the power 3 by 2 by 3 by 2, and this is 2 root x because the power is minus half plus 1 is half, so it becomes 2 root x. So therefore, we can see here 2 by 3 x to the power 3 by 2 plus 2 root x plus c is the correct answer. Next, integration of 2x minus 3 cos x plus e power x dx. So when I apply the integration for this, I'll keep 2 as a constant, integration of x, minus again 3 constant, integration of cos x, plus integration of e power x. So if I integrate them separately, then this is x square using the polynomial integration. Cos x is sin x and e power x is e power x. So we can clearly see here, this is x square by 2, so 2 and 2 get cancels. The answer will be x square minus 3x plus e power x plus c. When you look at the options here, so option B clearly is the answer. Next, integration of secant into secant plus tan x dx is. So options are given here, secant x minus tan x plus c, tan x plus secant x, tan x minus secant x, minus of secant x plus tan x. So before applying the integration, let us multiply this inside, then we get secant square x plus secant x plus tan x. When I apply the integration separately for these two functions, integration of secant square is tan and integration of secant tan is secant x. So therefore, tan x plus secant x plus c is the correct option. Next, if f of x is equal to 0 to x t sin t dt, then f dash of x is. So here actually derivative of the function will be given. First we need to find out what is f of x and then derive it. So what are the options here? Cos x plus x sin x, x sin x, x cos x, sin x plus x cos x. So before that, when I apply integration by parts for this function, so integration of t sin t with respect to dt will be t integration of sin t, which is minus cos t, minus integration of derivative of t, which is 1, integration of sin t, which is minus cos t with respect to dt. So we will get the answer as minus t cos t, minus into minus plus integration of cos t is sin t. So and when I apply the limits here from 0 to x, that is lower limit is 0, upper limit is x. So clearly, I'll get this as minus x cos x plus sin x minus 0. The lower limit is completely 0. So this is our f of x. Now derive this, that is f dash of x. So clearly when you apply here, this is a product rule. So first function, derivative of second. Next, second function into derivative of first. Again, derivative of sin x is cos x. Clearly here, cos x minus cos x get cancels. So we are left with x into sin x. So f dash of x is option B, that is x into sin x. Next, integration of minus 1 to 1 sin to the power 5x cos to the power 4x dx is 1 minus 1 0. So clearly here you can see this as f of x. And if you change it in the form of f of minus x, then it is sin power 5 of minus x, which will become minus sin power 5x, and cos power 4 of minus x is cos power 4x only. So clearly here f of minus x is equal to minus f of x, which is an odd function. We know that from the property of the integral that minus a to a f of x dx will be equal to 2 times integral 0 to a f of x dx if it is an even function, 0 if it is an odd function. Now here this is an odd function. So therefore the correct option is option C. Next, we'll move on to the 2-mark question. So here 2-mark question basically have integration by substitute type of questions or integration by parts. So we can also have a definite limits with integration by substitution. So look at the problem here. We have evaluate integration of sin x into sin of cos x dx. So since sin of cos x is given, let us take t is equal to cos x. So if we take t is equal to cos x, derive on both sides, then we will get dt is equal to minus sin x dx. So instead of sin x dx here, instead of sin x ds, I can substitute minus dt, and here I can make it as sin t. So this becomes minus sin t dt. Integration of sin t is cos t, minus cos t. So minus of minus cos t becomes plus cos t plus c. Now let us substitute what is t. T is cos x. So the answer is cos of cos x plus c. Evaluate integration of cos 6x root of 1 plus sin x dx. So let's take 1 plus sin 6x here as t. Then dt is cos 6x into 6. And with respect to x means we have dx. So instead of cos 6x dx, I can write it as dt by 6. So this will become 1 by 6 integration of root t dt, which is 1 by 6 t to the power 3 by 2 by 3 by 2. 2 ones are, 2 threes are. So clearly I can write this as 1 by 9, and t we have taken as 1 plus sin 6x to the power 3 by 2 plus c. So this is the value of the given integral. Next, integration from 2 to 3 x divided by x square plus 1. So here also let us take the substitution method. Put t is equal to x square plus 1. Then dt is equal to 2x dx. So instead of x dx, I can write this as dt by 2 and t as x square plus 1. So this will become integration dt by here, so 2t. And we also have the limits here. So when we have taken t is equal to x square plus 1, if x is equal to 2 here, then t is 2 square plus 1. So t is equal to 5. And when x is equal to 3 here, then t is equal to 3 square plus 1, which is 10. So the limits changes from 5 to 10. And if I take 1 by 2 as a constant, we will get here log t to the power 5 to 10. Since we have changed the limit of the function also, no need to put it back the value of t again. Just directly apply the upper and lower limit. So we'll get half log 10 minus log 5. And using the property of log m minus log n can be written as log m by n. So log 10 by 5 means it is half log 2. So this is the value. Next, Evaluate integral of tan power 4 root x secant square root x divided by root x dx. So here let me take t is equal to tan of root x. Then dt is equal to tan of root x can be secant square root x, and root x is 1 by 2 root x dx. So instead of secant square root x 1 by root x dx, I can replace it with 2 into dt, and then the remaining integral becomes 2 into dt. This becomes t to the power 4 with inside the integral. Let's take two constant. Let's integrate t power 4 with respect to dt. Then this will be t power 5 by 5 plus c, or 2 by 5 tan power 5 root x plus c. So this is the value. Next, integrate x into secant square x with respect to x. So integration x into secant square, it's a product function. So we'll apply integration by parts here. So integration of x into secant square x dx. So using the rule ILATE, that is how to give the preference for the function. So first, when you have two functions in the product form during the integration, inverse should be given the priority, later to the log, then algebraic, then trigonometry, then exponential function. So here it is already in the algebraic and then trigonometric form. So therefore we can directly integrate in this form only. So now let's integrate x into integration of secant square is tan x minus integration of derivative of x, which is 1. Again integration of secant square, which is tan x dx. Now finally we'll get x into tan x minus integration of tan x is log of secant x plus c. So this is the value. Next, 3-mark question. Evaluate integration of x divided by x plus 1 x plus 2 dx. So from 3-mark question, you can expect one question from integration by partial fraction. So this is an example for integration by partial fraction. So we have a function, a rational function in the form of x divided by x plus 1 x plus 2. So we'll separate this into two simple fractions, that is a by x plus 1 and b divided by x plus 2. We'll find the value of a and b and then we'll integrate. So after resolving this, we'll get x is equal to a into x plus 2 plus b into x plus 1. Now here let's find a and b by equating the factors to 0. First let us equate x plus 1 is equal to 0. If x plus 1 is 0, then x is equal to minus 1. So a into minus 1 plus 2 plus 0. So evaluating this, we'll get a is equal to minus 1. Similarly, if I put x plus 2 is equal to 0, then x will be equal to minus 2. Let me substitute here. So minus 2, x plus 2 is 0. So b into minus 2 plus 1. So we have minus 2 is equal to minus b, or b is equal to 2. Now instead of this, let me substitute the value of a and value of b and then integrate. So here integration of x divided by x plus 1 x plus 2 with respect to dx can be written as integration of a by x plus 1. So a by x plus 1 is minus 1 by x plus 1 dx. And b divided by x plus 2 becomes 2 divided by x plus 2 dx. Now integrating this, keeping the constant outside, let me keep minus 1 outside, then it is minus of 1 by ax plus b form is log of ax plus b. So therefore this becomes log modulus of x plus 1. And here we have 2 log modulus of x plus 2 plus c. We can also write this in the form of log mod x plus 2 whole square divided by mod x plus 1 plus c. Using the properties of logarithms, so this can be written as log x plus 2 whole square minus log x plus 1 means we can write it in the form of m by n. So this is the answer. Evaluate integral from 0 to pi by 2 cos square x dx. So we do not have any direct integration or any standard integral for function cos square x. So we can replace cos square x by using some other trigonometric identities. So cos square x can be written as 1 plus cos 2x divided by 2 with respect to dx. First, let us integrate this. So I can keep half outside the integral. Then I need to integrate 1 with respect to dx, which is x, cos 2x with respect to dx, which will be sin 2x divided by 2. Now let me apply the limit here, 0 to pi by 2. Here also 0 to pi by 2. Now let me keep half as a constant outside. So pi by 2 plus 2 into pi by 2 is sin pi divided by 2 minus x is 0 here plus again sin 0 is 0. So sin pi is 0. So this term is again 0. So we have pi by 2 into 1 by 2. So the value is pi by 4. Next, evaluate integration of x minus 3 divided by x minus 1 whole cube e power x dx. So here I'll convert x minus 3 as x minus 1 minus 2 whole divided by x minus 1 whole cube into e power x dx. And when you divide them separately, x minus 1 by x minus 1 whole cube is 1 by x minus 1 whole square minus 2 divided by x minus 1 whole cube into e power x dx. We have one of the standard integral, that is integration of e power x f of x plus f dash of x is equal to, with respect to dx, is equal to e power x f of x plus c. So here f of x is 1 divided by x minus 1 whole square. If you derive this function, you will get the answer as minus 2 divided by x minus 1 whole cube. So clearly using this property, the value of this integral can be written as e power x into f of x, that is 1 by x minus 1 whole square, which becomes x minus 1 whole square in the denominator plus c. Next, sin 3x cos 4x under the integral. So here, this is in the form of sin ax cos bx form. So now using the properties of transformation formula, sin 3x cos 4x can be written as half sin of x plus y form, that is 3x plus 4x, which is 7x, plus sin x minus y, that is 3x minus 4x, which is minus x. So with respect to dx. So let me keep half outside and let me integrate the given function. Now half outside, integration of sin 7x is minus cos 7x divided by 7. Now I'll take minus outside because sin of minus x is minus sin x, and sin of minus x, if you integrate, you will get minus cos x plus c. So let me multiply half, then it is minus 1 by 14 cos 7x plus 1 by 2 cos x plus c. Next we have integration e power x sin x. So here we can write the function in the form of e power x integration of sin x dx minus derivative of e power x integration of sin x dx again with respect to dx. That is integration by parts. So we'll get here minus e power x cos x minus derivative of e power x is e power x only. So we'll get e power x minus cos x dx. So if we go on integrating this function, so it will go on integrating throughout to the infinite number of steps. So what I'll do, I'll consider this as I. This as I. Then I'll take I is equal to minus e power x cos x plus I1. I'll take this as I1. Let me consider this as equation 1. Now let me integrate I1. If you integrate I1, again using integration by parts, you will get e power x sin x. Next, minus derivative of e power x is again e power x. Again, integration of cos x is sin x dx. But integration of e power x sin x dx is nothing but I. This is I. Now let me substitute I1 to equation 1. Then I is equal to minus e power x cos x plus e power x sin x minus I. So I plus I is 2I. I'll take e power x as a common factor. Then I'll get minus cos x plus sin x. So interchanging the values here, minus and plus, and divide by 2, I'll get I is equal to e power x divided by 2 sin x minus cos x. So this is the value of the given integral. Now we have 5 more questions here. So the 5 more questions is basically on the standard integral of the type 1 by root of x square minus a square. So here I have taken the proof of 1 divided by root of x square minus a square with respect to x. So let me consider this. So here if I consider this integral, I is equal to integral 1 divided by root of x square minus a square with respect to dx. So let me put x is equal to a secant theta. So put x is equal to a secant theta. Then dx is equal to a secant theta tan theta d theta. Also we can write theta as secant inverse x by a. So now if I substitute to the standard integral, the whole integral will become dx can be written as a secant theta tan theta d theta whole divided by square root of a square secant square theta minus a square. When we evaluate here, a square can be taken out of the integral and secant square minus is tan square. Under the square root it becomes tan. So the integral becomes a secant theta tan theta d theta whole divided by a tan theta. Now a tan get cancels. So we are left with integration of secant theta d theta whose value is log modulus of secant theta plus tan theta. And here only we can observe, if we need tan theta, it is square root of secant square theta minus 1. So therefore, log secant theta plus square root of secant square theta minus 1. Now we know that here x is equal to a secant theta, and if I need secant theta, this will be x divided by a. So therefore here the value is equal to x by a plus x square by a square minus 1 under the square root. So if we go on integrating this value finally, so we'll get the value in the form of log x plus square root of x square minus a square. So with the integration constant plus c. Now let us consider this 1 by root of x square plus 6x plus 7. So here this is a quadratic equation. I can write this as in the completing square method, adding plus 9 and minus 9. So here if you observe x square plus 6x plus 7, I'll add plus 9 and I'll subtract minus 9. So I'll consider this in the form of x plus 3 whole square and 7 minus 9 as minus 2, which can be written as root 2 whole square. So therefore this can be reduced the standard form of x square minus a square. So that is 1 divided by x square plus 6x plus 7 dx can be written as 1 divided by root of x square plus 6x plus 7 as x plus 3 whole square minus root 2 whole square with respect to dx. So using the standard integral form here, I can write log x value is x plus 3 here. So I can put x plus 3 and root of x plus 3 whole square minus root 2 whole square. This is root x square minus a square is nothing but this only, that is root x square plus 6x plus 7. So instead of this, I can directly write this as x square plus 6x plus 7 plus c. So this is the value of the given integral. So this is how we will find the proof of the standard integral and evaluate the given integral. Next question. Find the integral of root of x square plus a square with respect to x and hence evaluate root of x square plus 2x plus 5. Again, this can be written as completing square method, but let us find the proof of this. Now to find the proof of these integral, we have two more integral, x square minus a square and a square minus x square under the square root. We use the method of integration by parts. So I have taken one example of root of x square plus a square. So let me consider I integration of root of x square plus a square. I said we will use the method of integration by parts, but here it is only one function. So the other function I'll consider as 1 with respect to dx. Now I will apply the integration by parts here. So I is equal to, so I is nothing but root of x square plus a square dx here. So I is equal to first function into integral of 1 dx. Integral of 1 dx is x minus derivative of this function. This is in the form of root x. When we derive root x, the standard value is 1 divided by 2 root x. So therefore, with the whole integral, the derivative is 1 by 2 root of x square plus a square. Now since it's a composite function here, we need to derive x square plus a square again. So integration of x square is 2x and a will be 0. Now the derivative of the first function is done. Let me take the integral of second again. So integral of x is again x. So with respect to dx. So clearly we can see plus 2 cancels here. So here I'll get the value as x root of x square plus a square minus integration of x into x is x square divided by root of x square plus a square with respect to dx. Now here I'll make a slight changes by adding a square and subtracting a square. I'll separate these two terms and divide each term by root of x square plus a square. Then I becomes x root of x square plus a square. So minus I'll keep outside. So integration of x square plus a square divided by root of x square plus a square becomes root of x square plus a square with respect to dx, another integration. Then I have minus. I'll take a square outside the integral because it's a common. Then a square by root of x square plus a square is integration of 1 divided by root of x square plus a square with respect to dx. Clearly this can be written as I because I is square root of x square plus a square into dx. So I is equal to x root of x square plus a square minus I. Here because when we multiply minus here it becomes minus and minus into minus here it becomes plus a square integration of 1 divided by root of x square plus a square with respect to dx. So next I will take I here. This becomes 2i x divided by root of x square plus a square. Here plus a square. This is one of the standard integral, that is 1 divided by root of x square plus a square. So previously we have learnt the proof of 1 divided by root of x square minus a square whose value is log of x plus root of x square minus a square. Similarly, this is one of the standard integral whose value is log modulus x plus square root of x square plus a square plus c. Now here I'll divide by 2. So I is equal to x by 2 root x square plus a square by 2 log x plus root of x square plus a square plus c. So this is the value of the standard integral root of x square plus a square. Now we will simplify this. So we have square root of x square plus 2x plus 5 with respect to dx. So this can be written as 1 plus 4. So this is x square plus 2x plus 1 is in the form of x plus 1 whole square. And plus 4 can be written as 2 square under the square root. Now you can clearly see this is in the standard form of root of x square plus a square, where x is x plus 1, a is 2. So using this formula, we can write the answer as x plus 1 by 2. So square root of x square plus a square can be written. This is the simplified form of x square plus a square. So I'll write this only. So square root of x square plus 2x plus 5 plus a square by 2. A square is nothing but 4. So 4 by 2 is 2 log modulus x is x plus 1 and root of x square plus a square is this only. So root of x square plus 2x plus 5 plus c. So this is the value of the given integral. Now coming to 6-mark question, you have to learn the properties of integral, that is property number 4 to property number 7. So as we have done along the 5-mark question, we need to prove the proof of the standard integral and then evaluate the given integral. In the same way, under the 6 marks category, we need to learn the properties of integral and prove or evaluate the given integral for 6 marks. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.